Hi, this is Raphael Mudge, the creator of Cobalt Strike. Welcome to part 4 of In-memory Evasion, threat emulation. There's a few topics I want to cover here. Briefly, I'd like to describe threat emulation in memory. I'd like to discuss how to analyze a DLL and pull out characteristics that might be interesting for threat emulation. And then I'd like to show you how to apply some of that information you've pulled to Beacon, so that information will be available to an analyst looking at your activity. So what is threat emulation in memory? Well, it's populating the Beacon payload with tells or indicators from other malware. And that might mean values from the malware's PE header or similar strings. Why do I claim that threat emulation is changing PE headers and strings to look like other malware? Well, because these are indicators that analysts use to understand what they're dealing with. For example, here's a set of Yara rules presented earlier that have strings and PE indicators for the Beacon payload. And here's the same information from a virustotal.com sample. The theory is if you have enough indicators that match a known piece of malware, a known actor, an analyst who relies on these kinds of tools and indicators to understand what they're dealing with can be steered to think that that is what they're dealing with. All right, let's say there's a threat we want to emulate, and they happen to use malware that's compiled as a DLL. Well, how do we pull those headers? One option is to look at the information available in different kinds of malware analysis sandbox and mimic the headers there. Or you can use Cobalt Strike. Cobalt Strike does have a PE parser built in. It would make sense it has a parser because it has an editor too that's used internally. If you want to use that PE parser on the command line, there's the string to do so. Now with Beacon, what are your options to update and match various PE headers? Well, there's a few right now, a few coming, and probably more to come in the future. In Cobalt Strike 3.11, you'll be able to change the module name explicitly. You can change the compile time today. You can change the size of the file in memory. So those are some of the header options that you can actually set. Here's what it looks like to change the Beacon DLL to resemble some indicators from the HaveX Trojan. Here I'm setting the compile time of the Beacon DLL to the compile time of HaveX, and changing the reflective loader to run DLL, which is an exported function observed. And I'm using string replace to replace the Beacon module name, in this case, with the module name of the used in a HaveX sample. What about strings? Beacon's malleable PE does have the option to specify Unicode strings, normal zero-terminated strings, and just sequences of bytes using the string W, string, and data verbs. So here I'm adding strings to the Beacon DLL that were pulled from various Yara rules and sandbox string dumps. Okay, let's take a quick look at threat emulation using memory indicators. For this demo, we're going to use the HaveX profile, which is available on my GitHub repository. And the HaveX profile for Cobalt Strike pulls indicators from a variety of sources, including VirusTotal. The HaveX profile does do network traffic indicators, but it also changes Beacon's DLL, including a few of the headers, and it adds strings to the Beacon DLL pulled from reporting as well. And these strings come from things like this old blog post from F-Secure which documents a few strings in the HAVX Trojan, samples from places like payload analysis, and even looking at Yara rules that I could find for the HAVX Trojan. Okay, so let's come over here to Cobalt Strike. And first things first, we always run our profile through C2Lint. So let's go to APT, HAVX profile. And there we go. That's what our traffic looks like for this particular HAVX profile. No issues. Let's go ahead and start up a team server with the HAVX profile. And let's start up the Cobalt Strike client. Okay. Now, let's do our OPSEC analysis step. Let's go to Attacks, Packages, Windows Executable S, and we will just export our beacon bin file. Let's take a look at it. We're just going to run hex dump because that's one of the steps I suggested. And you'll notice that everything is intact as before. We've got the MZ header. This program cannot be run in DOS mode. Nothing about this profile is supposed to be really obfuscating. It's just supposed to look like HAVX. The other thing we want to do is verify that the strings we put into the profile are there. And if we run strings looking for wide character strings, we get back a list of strings embedded into the payload. And I should note that the Malleable C2 profiles, string W, string, and data verbs do put strings into the same section of the beacon DLL as other strings. Okay, that's good. Now, let's go ahead and take a look at some of the PE characteristics. We'll use Cobalt Strike's PE parser for this. You can use whatever you want, honestly. But this is here, so it's convenient for a demo. And we can see the timestamp of the DLL is 16 May 2014, which is what we would expect from the profile as the compile time. Let's take a look at the DLL's name and the exported function. And if you're used to looking at DLLs, this output will become kind of familiar to you quickly. But there's our export.name. So there's the beacon DLL name and the function we're exporting, which is Rundle. So that's an example of actually changing some of the PE characteristics with malleable PE as well. Now, if you were to run this beacon bin file against a Yara scanner that uses something like this HAVX rule, I'm pretty sure it's going to come up and flag HAVX. So that's your little bit of an extra option for threat emulation beyond network traffic, putting some things in memory for your analysts to find. All right, and I think a quick demonstration there kind of shows what I wanted to show. In this lecture, I talked about how to apply memory indicators and memory detections to the threat emulation problem. Took you through some options to analyze a PE, pull information out. Explained how to update beacon to take on some of those characteristics, and demonstrated some of these things in use. I hope you enjoyed that. This concludes part 4 of In-Memory Evasion. Good luck and happy hacking.